Hello, so today we're going to be doing MCMC using real RevBayes. In the last video, we manually wrote an MCMC function to perform an analysis, but here we're going to be using some of the built-in machinery within the Rev language to do that same analysis. So with that, let's jump right on in. Now, the first thing we're going to want to be able to take away is we're going to want to know the major components of an MCMC object and how to make those components, so that way we can build this object. And then next we're going to want to be familiar with moves and how we can assign moves to variables. And then lastly, we're going to want to know how to set up and run an MCMC analysis. So the first thing is the MCMC object. Now there are three main components that go into building this object, and those would be the three M's. I'll call them the model, moves, and monitors. The model, that's what we built in that first video with our coin flipping model. Next is the moves, and these are how we move around the parameter space. And then lastly are the monitors, and this is how we record where we are at in the parameter space as we're moving along it. So if we load up RevBayes, and we can type the MCMC function, which usually it has parentheses and things go in here. But if we type a function without any parentheses, we can see what inputs it all takes. And we can see that our MCMC function takes a few different things. I can't get it all to quite fit on screen. Maybe actually. No, okay. We're going to scroll up and down a little bit. But so the first three are the model, moves, and monitors, as I said before. And then there are a few other ones. These ones actually aren't required to be put into the function. They all have default values in with them. So I'm not going to be going over these very much or playing around with them at all, but I will just talk about them briefly. This first one, the move schedule. This determines how moves get used and what order they get used in. As you can see, there are a few different options for this move schedule. The default value is random, and that just says that it randomly will pick a move out of this move vector according to the weights of these moves. Next up is n runs, and that's if you want to do multiple independent MCMC runs at a time. This can be helpful for assessing convergence, or if you just want to run multiple and compare them. Next up is combine, and that's if you happen to do multiple runs. This tells you how they will get combined. And then n tries is as we're initializing the MCMC. This is how many tries you give the MCMC to initialize. And then lastly, we have prior heat, likelihood heat, and posterior heat. If you give any of these a value, it will raise each of these components to whatever power you give it, and that will affect the MCMC accordingly.